Good morning everyone. Welcome to today's lecture on composite materials. I, Ranjit Kumar, welcome you all for composite materials to discuss about it. Now, before getting into today's class, we'll have a brief recap about the previous topics which we have discussed in previous classes. We have covered all the manufacturing processes and we also dealt with basic introduction about the fibers, especially glass fibers, and we have also seen what are the different classifications of glass fibers in it, and we have already discussed about how to classify them and what are the different properties, and we have also seen one of the manufacturing procedures of glass fiber. Now in today's class we will actually start about discussing what is a fiber and what are the various things a fiber will have and what should be considered while selecting a fiber and all those things, right? Now, composition of fiber reinforced composites, as I said you, FRCs, fiber reinforced composite materials, right? Here in this slide we are going to see what is the basic composition of a fiber reinforced composite material is. In general, any fiber reinforced composite material will have two components in it, the first being fiber reinforced material and the second being a matrix material. Here any common fiber, any composite material which is being reinforced with a fiber will have these two things, the first being reinforcement and second being matrix. But though the fibers are acting as reinforcements and the main source of the strength, the complete strength, the complete bonding, the complete strength, the complete holding up of all the fibers will be done by using a matrix material, and this matrix material will be acting as a glue-like substance. It is holding the complete fiber materials, like it is acting as a glue-like substance, and it is holding all the fibers together in its required shapes, right? Now, the functioning of a matrix is also to transfer the stresses, all the types of stresses, let it be longitudinal, let it be axial, whatever, all the types of stresses will be transferred from outside to the reinforcing fibers, right? So apart from acting as a bonding material, this matrix is also transferring the stresses between the reinforcing fibers. Next, apart from this matrix material and the reinforcement material, sometimes we should also use some special type of materials, and those special type of materials are called as modifiers, or they can also be taken as fillers, right? So if you take 100% volume, sometimes it is not necessary to have a complete 100% of volume filled with these two materials, the first being matrix material and the second being the reinforcement material. Apart from these two, sometimes there will be some situations where we will also require some other types of materials, and those materials will be acting as filler materials. The main purpose of those filler materials is simply to fill up the complete volume, the leftover volume which is remaining after the reinforcement material and the fiber material are already placed in it, right? So sometimes fillers, which are also called as modifiers. Why are we calling these as modifiers? We'll be coming across these point in the next slides, okay? So sometimes fillers or modifiers will also be used so that we might be getting, or the manufacturing processes will become smooth enough, and we will also be getting some special properties, enhanced properties, or in some other times we will also use these filler materials to reduce the manufacturing costs, or to reduce the preparation cost of this particular composite materials, okay? Next, the fibers of fiber reinforced composites. What are the fibers we will be using? What are the common types of fiber materials we will be using in order to prepare this fiber reinforced composites? Before going into that, let us look at the first point, which is explaining us about the primary function of the fibers. The primary function of the fibers is to carry the loads, along their longitudinal directions. So their only purpose is to carry the loads along longitudinal direction, which is the primary function of those fibers, Okay, and apart from that, I mean, we have some different types of common fiber materials to be used as reinforcements, and these common types of reinforcing agents, fiber reinforcing agents, are listed out here, and that list includes the first being aluminium and some aluminium products like aluminium oxide, aluminium silica, and we also have asbestos, beryllium, beryllium carbide, beryllium oxides, carbon. Either carbon can be used directly in its purest form, or we can also use it in the form of graphite, right? And glass, right? As we discussed in the previous class, we have different categories of glass fibers. Among them, either will be using glass materials in the form of either E glass or S glass or D glass, right? So E, S and D categories are the only categories of materials, glass fibers, which we'll be using. And going on to the next one, it is molybdenum, right? So the first one is aluminium, aluminium oxide, aluminium silica, asbestos, beryllium, beryllium carbide, beryllium oxide, carbon, either in the form of direct pure form, or we will also be using in the form of carbide, graphites, and glass. Glass also we will be using in form of E glass, S glass and D glass, and then we have molybdenum, right? Next, apart from these, we also have a large variety of fibers which can be used, starting with the first one, that is polyamide, polyester, quartz. Quartz is also taken as fused silica, right? Quartz, steel, tantalum, titanium, tungsten, and tungsten monocarbide. These are the different categories of, or the different, this is the huge list of fibers which will be used as reinforcing materials, right? Starting with aluminium, then we have seen different types of boron compositions and glass compositions. Then we have these 8 different categories, the like polyamide, polyester, quartz, steel, tantalum, titanium, tungsten monocarbide. So we have made a list of 18 different categories, 18 different types of fibers which are available to us in the market, by using which we can prepare fiber reinforced composite materials. Okay, moving on to the next slide, the matrix. Till now we have seen the reinforcement material, which is nothing but our fiber. Now we are going to see what about the matrix here. The matrix of a reinforced fiber, fiber reinforced composite. What is the primary function of a matrix? The primary function of a matrix is not only to hold the fibers together, but it also has the ability, it also has the function, its function is also to transfer the stresses between the reinforcing fibers from one fiber to other fiber. If you have, for example, 10 fibers which are laid up parallel to each other uniformly in same direction, the primary function of this particular matrix is to transfer the stress from fiber 1 to fiber 2, and fiber 2 to fiber 3, and fiber 3 to fiber 4, 4 to 5, 5 to 6, 6 to 7. That means between the fibers, right? So the primary function of the matrix material which is used to prepare a fiber reinforced composite is not only to hold the fiber materials together, but also to transfer the stresses between each and every reinforcing fiber, okay, and also to protect the fiber from mechanical and environmental damages. For example, let us assume that this is a material made up of fibers, and it is a fiber reinforced composite material. If by any chance I drop this material onto the ground, it will experience a sudden impact, right? It will be experiencing sudden impact. Some stresses will be induced into it. Because of those stresses, there might be a situation that the component will undergo some damage, right? Let it be due to mechanical forces, let it be due to sudden drop, let it be due to environmental changes, or whatever the thing is. The matrix material will also act as a protecting material on the fibers from all the mechanical damages which are possible, and also from environmental damages. Okay, so this is the function, the primary function of a matrix material. Now, what is the basic requirement of a matrix material? As we already know that in order to prepare a fiber reinforced composite material, we should have both the fiber materials which are nothing but our reinforcements, and matrix material. Now, what is the basic requirement of a matrix material? The basic requirement of a matrix material is that its strain at break must be larger than the fibers it is holding. Whenever the material is undergoing breakage, at that particular point, the strain of the matrix material should be much more when compared to the strain of the fibers within which it is holding. For example, if I take a material which is made up of composite material, let us take it as a fiber reinforced composite material. If the strain of the matrix material and the strain of the fiber material at the break both are same, then obviously the object, whenever it experiences such type of impacts, it will easily break into two parts, which is of no use to us, right? Even the fibers inside the matrix material undergo splitting or breaking, the matrix material should hold it such that the intended purpose will be serving. Okay, so the basic requirement of such a matrix material is that it should have the strain, which is taken obviously at a break, which should be very larger when compared to that of fibers, the fibers which is being holded by the matrix material, right? And most of these matrices are generally made up of resins. We are discussing about these resins since number of classes. This is not the very first class we are talking about these resins. We are talking about these resins since the inception of this particular subject, right? So resins, most matrices are made up of these resins for their wide variation in properties. What properties we do have? Mechanical properties, chemical properties, thermal properties, fluidity, viscosity, and we have lot of properties that can be discussed. It will take a minimum of 1 or 2 hours if you start discussing about the properties of those resins, right? We are not actually discussing about them, but we'll see what are the basic requirements of a matrix material here. So most matrices are made of resins for their wide variation in properties and relatively low cost. Because whenever you want to prepare a composite material, you have to consider two basic ingredients, the first being fiber material, also taken as a reinforcement material, and the second being a matrix material, right? If the cost of these two materials is high, then obviously initial cost is increasing. As initial cost is increasing, the final production cost or the product cost which is available, at which it will be available in the market, will be more. If the cost at which it is available is more, then it doesn't serve its intended purpose, right? So the most of the matrix materials are made up of resin materials because they will showcase wide variations in their properties, and also they will be having relatively low cost. Okay, and all the materials are readily available to us, most widely available to us, right? Now, as we have seen what are the common fibers which we can select or which we can use, we are also going to see what are the most common resin materials, right? In this resin materials, we have different categories again, different classifications again, and the first classification is taken as first category is generally named as a resin matrix. And what is this resin matrix? This resin matrix is a matrix which is using resin as the holding material. And under that I have listed down some things. Let's start going through them. The first being epoxy, the second is phenolic, the third being polyester, and the fourth polyurethane. It's a bit complicated word, so polyurethane, and fifth being vinyl ester. And among these resin materials, I'll again go back to this slide. Among these 5 different resin materials, among epoxy, phenolic, polyester, polyurethane, and vinyl ester, you can clearly see that polyesters are the most widely used materials even till today. Why polyesters are most widely used materials? Though it is a domestic application or a commercial application, or let it be a small scale production or a large scale production, we will make use of polyester most widely because it has its own advantages, right? Epoxies which have higher adhesions. Adhesion means bonding things, right? It is holding. It's a property to hold. It's a ability to hold, right? So epoxies which have higher adhesion and less shrinkage less shrinkage than polyesters come in the second place for their higher costs. So polyesters, when compared to these epoxies, will have a bit higher cost, and therefore polyesters will be occupying the first position, and the epoxies will be occupying the second position, when the most resin material which is used, when you list out as per the most used materials, this will be the positions occupied. The first will be taken by the polyester and the second will be taken by the epoxies. Okay, and next, although non-resin matrices are also available, it is not necessary that we only use resin matrices. It is not necessary that we only make use of resin matrices so that we will be serving all the intended purposes. No, sometimes we will also use non-resin matrices. And what about non-resin matrices? We have metal matrices and we have non-metal matrices. Right. So how to classify them, how to separate them, how to differentiate them, what is a metal matrix and what is a non-metal matrix? Now let's go into that things. Okay, though these metal matrices and non-metal matrices are less commonly used, non-resin matrices can still be found in large range of applications because of their higher performances. What are their higher performances? How can we get where can we use those high performances? At elevated temperatures. At elevated temperatures, even though the temperature is very high, even at harsh conditions, these matrices, that means non-resin matrices, which are mostly metals, right? So these non-resin matrices will be showcasing better performances, and especially because of these property, this type of matrices will be used in defense industries. Okay, now let's make a list of it. First, let's start discussing about the metal matrix. What is metal matrix? The matrix which is using metal as a holding element or a bonding material, right? Under that, I have the first as aluminum and the second as copper. Next, lead, magnesium, nickel, silver and titanium. So these are the 7 different types of metals which will be used as a metal matrix. The first being aluminum, the second being copper, third being lead, fourth being magnesium, the fifth is nickel, sixth is silver and the seventh is titanium. Apart from this, we also have another category of matrices, non-resin matrices, and that is called our non-metal matrix. And what about non-metal matrix? How many categories do we have? Generally, we are taking only one category under that, that is ceramics, right? So 7 different metals can be taken as metal matrices and ceramics can be taken as a non-metal matrix. And these, you know what is a ceramic, right? Ceramic is a product which is obviously it's a very good insulator of thermal energies, and it's a very good insulator of electrical energy. That means even at elevated temperatures, even at very increased high temperatures, they do not conduct heat energies. These do not conduct thermal energies. That's the reason this type of matrix materials will be used mostly in defense industries, right? Defense industries, aerospace industries and so on. Now, modifiers, right? We have discussed about these filler materials or modifier materials in the first 2-3 slides. What is the actual purpose of this modifier? What is this actually doing? Why we are utilizing a modifier? Why do we need a filler material when preparing a fiber reinforced composite material? As I said there are 3 purposes to serve. The first being, it is not always necessary to get required properties by using simply resin and fiber matrices, reinforcements. So therefore, in order to have better properties or enhanced properties or increased properties, we will be sometimes using filler materials, which are also called as modifiers. Since they are modifying the properties, they are also called as modifiers. And the second purpose is to simply fill up the space. See, if you take 100% volume, in that 100% volume, it is not necessarily all the time required to fill up the 100% by using those 2 basic ingredients, the first being fiber and the second being matrix material. Sometimes it is okay if I fill up the complete if I fill up to only 60 to 70% of the volume by using those two products, but I have to get 100% material. Therefore, the remaining amount of the space or the volume available, 30% or 40%, it depends upon the filling, it depends upon the quantity which we are using. So that amount can be filled by using these fillers. Okay, and that's the second purpose. And the third purpose, to reduce the cost of production. As I have already said you, we will also experience reduction in cost of manufacturing whenever we will use these filler materials. Therefore, this is also important to study. We also should study about these filler materials or modifiers, right? So let's start looking into it. What is the primary function of this particular additives? Additives are nothing but the modifiers or fillers which we are using, right? As I said you already, to reduce the cost, to improve workability, ability to work, and also sometimes it is compulsion, or sometimes it is it's an alternation to impart the desired properties, or that means to imbibe, that to incept desired properties or to enhance the properties, right? And the following will be the desired properties which can be attained by using modifiers or filler materials. So we will have a particular point in our mind that, okay, if I mix up these type of modifiers, I'll be getting these type of properties. So let's make a list of the desired properties which will be obtained whenever we will be using these fillers or modifier materials, right? Let's see into it. Cost reduction. Whenever you are talking about cost reduction, obviously low cost to weight ratio will be taken into consideration, right? Low cost to weight ratio may fill up to 40% of the total weight, right? Sometimes like these filler materials, as I said you, the two basic ingredients like fibers and matrices, it is okay if I fill those two materials up to 60% of the volume. The rest 40% will be filled by this filler material, so that the cost will be reduced. Some cases it might even go up to 65%, that is maximum limit. Okay, next, improvement in workability, like reduction in shrinkage. Air release, it helps in releasing air, like we already discussed that whenever you want to prepare, whenever you want to fabricate a composite material, you should make sure that there is no presence of voids in that material. Voids means air gaps which are present in that material. If any presence of air is there, then obviously at a point of time when the air experiences huge pressure, it blasts and it tends to deterioration of the material, and all such things happen. Therefore, there should not be any presence of air. In order to have that presence of air, wherever we have these possibilities to have to create those air voids, there will be using these fillers. Okay, so it helps in removing the air, therefore helps air release. Then, and the next one, decrease in viscosities, right? Decrease in viscosities. Okay, next, the control emissions. Whenever we are performing vacuum operations, sucking operations, like there are multiple procedures in which we will be using that vacuum bagging, and will have a suction pump, and will be sucking the complete air from the sealed bag from inside to outside, so that the resin will start flowing from one point to other point as a process. It will be completely flowing onto the particular fiber materials. That means it is wetting. Okay, the fibers will get completely impregnated. So here what happens is, whenever you are using a filler material, obviously the amount of resin is increased, therefore the amount of emissions, harmful gas emissions, can be controlled. Okay, now next, coefficient of friction on the surfaces can be reduced. Obviously, we will have a reduction in coefficient of friction on the surfaces. Okay, next, the molds, or which are also taken as guide resin flows, they can be sealed. For example, I'll take an inlet through which I'll be passing the resin, and that resin, after getting passed for a point of time, for a period of time, there might be a chance that the seal is not properly done, right? The material is not getting properly sealed. So such things can be easily sealed, or the guide flows can be prepared by using these filler materials, right? And we can speed up the process, curing process, or we can slow down the curing process, and we can sometimes initiate the curing process, right, by using these filler materials. Therefore, filler materials, which are also called as modifier materials, are really important. Not all the times, but sometimes they are really important for us to consider, so that we'll be having desirable advantages, and we can also have controllable processes and so on. Okay, moving on to the next slide. Property enhancement. Of course, this property enhancement is also one of the desirable properties to consider these filler materials or modifiers while preparing a fiber reinforced composite material. Okay, now what are the property enhancements we can have? Like you can see, there are a lot of improvements which are done here in the slide. So we can improve the electric conductivity, right? Like I said, you filler material can be either even sometimes it can be taken metal, right? So we can improve electrical conductivity, we can improve fire resistances, and corrosion resistance can be improved, and ultraviolet resistance can be improved, surface toughness can be improved, and we can also imbibe heat transfer stabilizations, right? We have a lot of property enhancements that can be done by using a modifier, starting with electrical conductivity improvement, fire resistance improvement, corrosion resistance improvement, ultraviolet resistance improvement, surface toughness improvements, and stabilizing the heat transfers from one point to the other point. Apart from those, we also have multiple amounts of property enhancements. That means we can sometimes add desired colors whenever we want. I don't want a plain color, I don't want a single color, I want a multiple colored material. So I can have addition, I can use a filler material which will be providing me a chance or an opportunity for adding required my favorable colors onto it, right? So I can add desired colors, and I can also sometimes reduce the tendency of static electric discharges or charges. You know what is static electric charge, right? Whenever you rub plastic material onto other material, and sometimes you might be feeling when you have a sudden contact with the material or a skin or any other material, you'll have some tickling effect, right? That's called static electric energy transfers, right? So we can also reduce such type of things. Static energy, though you feel that the static energy is very low, is obviously under controllable limits, but static energy can sometimes damage internal tissues of a human body so badly, you know that, right? So therefore we can also reduce such tendencies of static electric charges. Next, the common materials which can be used as additives, or which are nothing but our filler materials, or the same can be taken as modifier materials like filler materials. We again have these two or three categories. Let's see into each and everything. Filler materials: feldspar, glass microspheres, glass flakes, glass fibers which are milled glass fibers, mica, silica, talc, wollastonite, and other microsphere products, right? I'll again repeat this list of filler materials. The first one starting with feldspar, the second glass microspheres, and the third being glass flakes, and the fourth milled glass fibers, mica, silica, talc, wollastonite, and other microsphere products. Okay, now what about modifier materials? As I said, additives can be both categories, can be taken into both categories, the first being filler material and the second being a modifier material, right? Now what about the modifier materials? How many types of modifier materials can we use here? The first being organic peroxides. What organic peroxides do we have? Basic example we have here is methyl ethyl ketone peroxide. Methyl ethyl ketone peroxide, MEKP, right? Next, benzoyl peroxide, tertiary butyl catechol, TBC, and dimethylamine, DMA, zinc stearate, waxes, silicone, and fumed silica and clays. See, these are the different categories of modifying materials we can use, right? Apart from this, apart from the filler materials, right? Modifier materials. What modifier materials do? They modify the properties. What properties they modify? They modify electrical properties, they modify mechanical properties, they modify fluid properties, they modify resistances, they increase resistances towards corrosion, they enhance a lot, right? So these modifier materials, among these 7, the first being organic peroxide, benzoyl peroxide, tertiary butyl catechol, and dimethylaniline, and zinc stearate, waxes, silicones, and fumed silica along with clays. These can be used. Any one of these can be chosen as a modifier material, so that we will be getting a better property, or we will be getting betterment in the properties whenever we are preparing a fiber reinforced composite material. Okay, so in the next class we will see about glass fibers, how are they prepared, and what types of glass fibers we do have, what are their properties, and so on. Okay, so we'll meet in the next class for discussing that. Thank you.